Good morning, my dear friends. So we shall see this third problem in calculating this ultimate strength of PSC sections. Okay, so I will read the problem now. A pretensioned T section has a flange 1200 mm wide and 150 mm thick. As you see, the T section has BF is equal to 1200 mm. Okay, breadth of the flange, and DF, thickness of the flange, is 150 mm. Okay, so now the width and depth of rib are 300 mm and 1500 mm respectively. Okay, the width he has given BW. Okay, width of the rib is 300 mm, and this depth of the rib is now 1500 mm. Okay, 1500 mm. Okay, so now the high tensile steel has an area of 4700 mm square. Okay, so area of steel whatever he has kept here, it is 4700 mm square, and is located at an effective depth of 1600 mm. Okay, so he has given the effective depth D from the topmost compression fiber to the CGS. Okay, so this is effective depth, he has given it as 1600. Okay, if the characteristic cube strength of the concrete and the tensile strength of steel are 40 MPa and 1600 MPa, okay, he has given FCU and FP. Oh, sir, no? FCU, in sense now, it is the characteristic compressive strength of concrete, FCK, okay, and FP is the characteristic tensile strength of the steel, 1600 MPa, okay, respectively. Calculate the flexural strength of the T section. Okay, he has asked you to calculate the ultimate flexural strength. Okay, so now as usual, in sense now he has given FCK is equal to 40 MPa, as I have already explained you. FP is 600 MPa. Area of pre-stressing steel is 470 mm square. Okay, effective depth D, as I have already explained you, it is 600 mm. Breadth of flange BF is 1200 mm. Depth of the flange DF is 150 mm. BW is 300 mm. Okay, so everything is now known. Okay, there is no confusion at all. So now I will try to calculate the effective reinforcement ratio. Okay, FPAP by FCKBD. I have already said you need not remember this. It is there in table number 11. Okay, so now I want to calculate this. Okay, so everything you know, FP is you know, AP also you know, FCK is known, breadth means now it is breadth of the web. Okay, sorry, it is breadth of the flange, it is now. Okay, it is so much 1200 mm, and effective depth D is 600 mm. Okay, so now while calculating this, I am now assuming that the neutral axis lies in the flange. Now I will assume that the neutral axis lies in the flange. Okay, so that it will act as a rectangular section only, not as a flange section. So now I will assume that it is neutral axis lies in the flange. Then I will calculate this effective reinforcement ratio. So it is now 0.10. It will give me an answer of 0.10. Okay, so now as you know, once I come to know this value of this effective reinforcement ratio, now I have to go to table number 11. Okay, see now from table number 11, for this value of 0.1, I have to find out this FPU by 0.87 FP. Okay, so now I will show you. Your FPAP by FCKBD is 0.1. Okay, so now it is pre-tensioned beam as you have seen. Okay, so now FPAP value is now 0.1. 0.1 is now here. Am I right now? 0.1 is here. So now your FPU divided by 0.87 FP value is, for pre-tensioned beams, these are the values. For post-tensioned beams, these are the values. So for 0.1, since ours is a pre-tensioned beam, it is 1. Am I right now? So FPU divided by 0.87 FP value is 1. Okay, so I have written the same thing now. FPU divided by 0.87 FP value is 1. Okay, so now if I cross multiply this, okay, you will get FPU value. Okay, FPU is equal to 0.87 FP into 1. Okay, so now 0.87 FP value you know, okay, into 1, it will give me 1253 MPa. Okay, similarly now we will try to calculate XU by D value for the same this thing now. Okay, XU by D value is now here now. Okay, XU by D is now here. Okay, so now again for point 1, see now XU by D value for pre-tensioning the values are here, for post-tensioning the values are here. Okay, so now again I will take this point 1, I will come here now, XU by D value is now 0.217. Am I right now? 0.217, since it is a pre-tensioned beam. Okay, so now it is XU by D value is now 0.217. Am I right now? So now if I cross multiply it, I will get the value of XU. XU value is now 0.217 into D. So now 0.27, effective depth 1600. So we will get 347.2 mm. See now, in the sense, neutral axis lies at a depth of 347.2 mm. In the sense, 347 mm means, Baba, your flange depth is 150 mm. So now it means that your neutral axis lies beyond the flange. 347. 347 means somewhere here it will come. Okay, from here to here, 347. In the sense, your neutral axis is lying beyond the flange. In the sense, it lies in the web now. Okay, it lies in the web. So, but now, whatever we have assumed here now, we have assumed that the neutral axis lies within the flange. Now this statement is wrong. Okay, this statement is wrong because your XU is greater than DF. Since your XU value is greater than this DF value, the neutral axis assumption of lying in the flange is wrong. Therefore, it lies in the web. So now, since it lies in the web now my all calculations have to be now it will now change now. Okay, so now see now what I should do is now 1 minute. Now see now so now we know now whenever the neutral axis lies in the flange, okay, excuse me, whenever the neutral axis lies in the web now, in the web, so now I have to, that I need AP can be written as APW plus APF. Am I right now? In the sense, your total pre-stressing area is now, it is divided into pre-stressing steel required for the web portion, pre-stressing area required for the flange portion. APW plus APF will give me total AP. Also, that APF can be calculated by one equation. APF is equal to 0.45 FCK into BF minus BW into DF minus DF by FP. Baba, all the values are known. 0.45 is 0.45, FCK value is 40, BF 1200, BW is 300, DF is 150, FP is 1600. So now I can easily calculate the area of pre-stressing force required for the flange. It is 1518 mm square. So once I know APF, from this equation, I know here AP, I know APF. So I can easily calculate this APW. So APW can be written as AP minus APF. Okay, total AP is 4700. It is given in the problem. APF is just now we have found 1580. Okay, so it will give me APW as 3182 mm square. Am I right now? It will give me 3182 mm square. So but now once I know APF and APW, now we shall try to calculate the effective reinforcement ratio. Okay, so now the effective reinforcement ratio is given by APW FP divided by BW D into FCK. Okay, APW it's here 3182, FP I know 1600, BW it is 300, depth, effective depth is 1600, FCK is 40. So but now this effective reinforcement ratio, now it will become 0.265. Now this is our new effective reinforcement ratio. Okay, so it will give me 0.265. So but now for this 0.265, now from table number 11, again I have to find the value of FPK divided by FPU divided by 0.87 FU. Okay, so now see now I will show you this page number, this thing now. So this is your effective reinforcement ratio. So now your effective reinforcement ratio is now 0.265. Am I right? So now this 0.265, it lies in between 0.25 and zero point 0.3. Am I right now? It lies in between 0.25 and 0.3. Is it right? So now here the values are for pre-tensioning, the values are 1 and 1 again. Okay, so no need to have any interpolation. So the value is 1 only. Okay, so the FPU divided by 0.81 FP is 1 only. So but now if I cross multiply it here now, I will get the value of this FPU. Okay, so FPU value is 1392. Okay, so now I have to calculate now XU by D ratio. So again now 0.25 is here, 0.3 is here. So if I see now XU by D value is now 0.542, and for this 0.3 ratio it is now 0.6655. Am I right? So again now from these two I have to interpolate the value now. Okay, so now I have written here now for this ratio of 0.25, XU by D ratio is 0.442, and for this 0.3, XU by D is now so much. So now again by interpolation I can calculate the value of XU by D. Baba, I think I have already explained you how to write this thing for interpolation. So now XU by D value works out to be 0.575. So now once I know XU by D is so much, so now I can cross multiply and take the value of XU. XU is now D into 0.575. Okay, so I know D value, fill it up here now. So I will get the value of XU as 921. So now when the neutral axis lies in the web, you know that ultimate moment of resistance is given by, okay, this is the contribution of your flange, this is the contribution of your web portion plus this is the contribution of your flange portion. You know this equation. Okay, fill up those things now. FPU I know, APW you know, D is effective depth, 0.42 is 0.42, XU just now you have calculated, it is 921 plus 0.45 is 0.45, FCK value you know, BF you know, BW you know, okay, DF you know, okay, into D minus 0.45 DF, okay, all the values you know. So now if you calculate, the ultimate moment of resistance works out to be 2470 kilonewton meter. Okay, this is how now you can calculate it. Okay, thank you very much.